Hello, today we will start with exercise 9.1, chapter 9.1 on circle. This chapter is based on circles. So from question number 1 we are starting, but before to that starting we will explain two theorems, 9.1 and 9.2. And based on this you have a question number 1 and question number 2. So theorem 1, 9.1, what it says, equal chords. Chords means this lines DC and AB. These are chords. Equal chords subtend equal angles. Means this line and this line is equal. It will make a equal angle here. Here and here angles will be equal. So subtend equal angles at the center. Okay. And another is next. I will explain while doing the next question number 2. So question number 1, what it says, you have to prove equal chords subtend equal angles at the center. Means angle AOB means this angle, and angle DOC, these angles are equal. Okay. So what is given here? Here it is given two chords AB and DC. AB and DC are two equal chords. AB and DC are two equal. Now in this triangle and this triangle we are going to prove. So in this triangle OA and OD, OA and OD, here it is the center, and from center any line which touches the circumference of the circle, it is radius. So this radius and this radius will be equal radius, and like this one BO and OC are also radius. So this will be also equal. Why we have written it earlier? Because while writing it takes too much time. That's why we are first writing and then we are explaining. Then AB and DC, this line is given equal. It is already given. So this triangle and this triangle are congruent. So AOB triangle and this triangle are congruent. That's why angle AOB, this angle will be equal to this angle. That is the congruent part of the congruent triangle, corresponding part of congruent triangle. So it will be equal. So likewise you have proved this. Equal chords subtend equal at the center. Now we are going to question number 2. I will rub and write question number 2. Now question number 2. Question number 2 says, prove that if chords of congruent circle means any circle whose radius is equal. Whose radius are equal, they are congruent triangles. So circle. So congruent circle subtend equal angles at their center. Then the chords are equal. What it is saying, in congruent triangle, if the angle here subtended at the center is equal, then the chord will also be equal. Means BC will be equal to EF. Here what is given, a circle is given, two circles are given which are congruent. It means this radius and this radius are equal, and you have to prove this line is equal. Okay. So equal angle, what is the question? Equal angles of congruent circle. Equal angles of congruent circle subtend equal chords. Okay, this is your question. Given in nutshell, in short, I have written the question. So given two congruent circle A and D, having the center A and D is given. So how we can prove? We can prove in this circle and this triangle. What AB and DB? AB and DE are equal because they are the radius of congruent triangle. AC and DF are also radius of congruent triangle. So being radius of congruent triangle, they will be equal. And this angle and this angle BAC and angle EDF, these are given equal as per the equal angles of congruent circle. That's why it is given. So based on side, these two, this and this triangle will be congruent based on side rule. So when these are congruent, it means this line will be equal to this line. BC and EF will be equal. So corresponding part of congruent triangle. So in this way we can prove our question number 2 also. Now we will go to exercise 9.2 question number 1. From there we will start. Now exercise 9.2 question number 1 we are going to solve. So these questions are based on theorem 9.3. 9.3 what it says theorem? Perpendicular from center means perpendicular from the center, like this from here. If you draw a perpendicular, like DC is a perpendicular on AB. So perpendicular from center to a chord. Chord is here AB. So AB is the chord and DC is the perpendicular. Perpendicular from center means 90-degree angle it is creating here. So perpendicular from center to a chord, bisect chord. Bisect chord means this AB will be divided in two equal parts. AC will be equal to DB. Based on this, and this is opposite to this theorem, just reverse of this theorem. So based on this question is given. So what you have to prove? Two circles of radius 5 centimeter and 3 centimeter. Two circles, one is this circle and one is this circle, having the radius of 5 centimeter and 3 centimeter, intersect at 2 points. Intersect at 2 points means at point A and point B. These circles are intersecting each other, means cutting each other. So this circle is cutting this circle at point A and B, intersecting at 2 points, and the distance between their centers is 4 centimeter from D to E. Center of this circle is E and center of this circle is D. So distance between their centers is 4 centimeter, means DE equal to 4 centimeter. It is given DE is equal to 4 centimeter is given. So DE distance between two centers is 4 centimeter. It is given. Radius of two circles 5 centimeter and 3 centimeter is given. What you have to find? You have to find length of common chord AB. So length of AB you have to find out. Okay. So if you can find out the length of AC, then AC is the double of AC plus CB are equal, and both together is the distance of AB. So we will try to find out first AC and we will make double of it, and the common chord distance we can find out. So here DE will be perpendicular. So I have explained to you. So AC and CB are equal because based on this theorem 9.3, perpendicular from center to a chord, bisect the chord. So what do you have to prove? So how you can prove? Now in this triangle, first we are discussing this triangle and then we will discuss this triangle. So by this red we have made a construction. Constructions means join here. Construction also you have to write. Okay, in the questions you have to write constructions also. So construction also you have to write. Construction means construction join AD and AE. This you have to join, and join DB and EB. These constructions you have done. By red I have done it. So dotted lines are constructions. Now we are going to prove in this circle. First we are taking this circle. So DA and DB will be equal to 5 centimeter being the radius of the circle, and EA will be equal to E and B. These are also radius. So the distance is given. Now we have assumed DC. This is DC equal to X we are presuming, because total length 4 centimeter is given. DC D is 4 centimeter, but DC length is not given. So we are presuming DC as the X. So EC will be 4 minus this portion. Total is 4 centimeter. From 4 centimeter, if you reduce the other this EC, so EC will come. So EC is equal to 4 centimeter minus D and C. D and C you have taken as X. So this we have proved. Now using our Pythagoras theorem, because this is perpendicular. Perpendicular means 90-degree angle it is creating. So Pythagoras theorem we can use here. So Pythagoras theorem, what it says? Perpendicular, this hypotenuse square, DA square is equal to perpendicular square plus base square. So AC square plus DC square, it is equal to this. So DA 5 is given, 5 is the radius, given equal to the AC square plus X square. X you have taken, you have presumed X, DC you have presumed as X. So here 25 equal to AC square plus X square. Now we are solving 25 minus this side, transposing it to this side. LHS we are transposing it. So AC will be equal to AC square. AC square will be equal to this much. So in the similarly same way we can go with this triangle also ACE. So in triangle EAC, what happens that EA square, EA means hypotenuse square, is equal to AC square plus Cbse perpendicular and base square. Now EA is given, EA is 3 centimeter being the radius. So EA is 3, AC square plus EC square. EC you have already found out 4 centimeter minus X. So in place of EC we can use this one. So here this we are using it EC. EC we are using from here. Okay, we are using it. So EC square 4x minus X. So here A minus B square, the formula we can use is equal to A minus square is equal to A square plus B square minus 2AB. Minus 2AB. It comes as like this. So here we have solved it. Now I will rub the other thing, and from this portion, this and this, we will start again. This is our point number 1. This is our point number 2. From using these two, we will solve the question. Now from the last what we have written, from there we are coming here. So this is our equation number 1, what we have proved earlier. 25 minus X square is equal to AC square. This is our equation number 1. And from where we have in the previous slide we are having at this point. From here we are again starting. From here we are again. So again I have written the same line. 9 equal to AC square plus this we have used as A minus B whole square. We have used it. And in the previous slide we are explained it. Now we are solving it. So it will come to this side and AC square, and this figure will remain. Now here it will be 7, and here it will be, will transpose this plus will become minus, and this minus will be plus, is equal to AC square. Now AC square we have already proved. So in place of AC we can use this value also. So value of AC square used from this, from here, and from equation 1, from equation 1 we are using. So this we have, AC we have put the value. Now again we are transposing, so X square will come to this side, minus figure will become plus. Okay, and this 7 we are taking to other side, so this minus figure will become plus. So this will cut off, this will go out, strike off. So 8x is equal to 32, x is equal to 4. Means what we have presumed is DC. DC we have presumed as x. So x is equal to 4. It means from here to here, from this line to DC, it is 4 centimeter. Now we have proved it is 4 centimeter. 4 cm we have find out. So this line we have find out, this line, so only AC we have to find. So again using the Pythagoras theorem, AC square. So AC square is equal to hypotenuse square minus your base square. So this we have put the value. DA is equal to 5 because it is the radius, and 4 we have find, DC we have find out. So it is equal to 25 minus 4 the 16. So 25 minus 16 under root 9 will come. So from here, if you will reduce, if you will strike off this square, it will become square root will come to this side. Now square root 9's square root is 3. It means AC is equal to 3. So AB will be, AB is the double, because this line and this line is equal. AC and CB are equal. AC and CB are, this CB is equal line. Equal lines AC and CB is equal. So AB will be double of AC. Double of AC we can do. So answer will be 6 centimeters. By this way your question number 1 is over. Now we will solve question number 2. Now question number 2. Question number 2, what it says, if two equal chords of a circle, two equal chords AB and CD, AB and CD are equal chords. Two equal chords of a circle intersect within the circle, at point E, intersect at point E within the circle, then you have to prove that the segments of one chord, segment means one piece, segment of one chord are equal to corresponding segment of the other chord. Means segment means piece. So suppose this piece and this piece, it has two pieces, and here also one piece and this is other piece. What we are going to prove, this one piece is equal to this piece and so this piece is equal to this piece. Two things, two times you have to prove. Means you have to prove segment of the chord. This segment is AE is segment and ED is one segment, and other is CE is one segment and EB is one segment. EB equal to EB equal to EC also you have to prove. So segments you have to prove. Now to prove this, what we have done, we have constructed, we have drawn a from the center we have drawn a perpendicular on line AB, perpendicular on line AB, and CD we have drawn a perpendicular. So what perpendicular will do? Perpendicular will kill a 90-degree angle here and 90-degree angle here. Both will come here. Okay, and these chords are equal. Okay, so angle A, so AL equal to L and B, because the any perpendicular from the center to the chord bisect the chord. This we have theorem we have used earlier also. It means this line is bisecting the chord AB. Okay. Similarly, CM is equal to MD, because from the center we have drawn a perpendicular. Perpendicular from the center to the chord bisect the chord. This is the theorem. So this will be equal. You don't go on the picture. Actually, in picture we have freehand drawings we have made, but this is the theorem. So as per the theorem, this CM will be equal to MD. Okay. Now we are going to prove in circle this triangle and this triangle. Triangle OME we are taking, and triangle OLE we are taking. So this line is common line. OE is the common, and OL and OM will be equal. Why equal? Because equal chords are equidistant from the center. Center is O. So this line, this LO and OM will be equal, because these lines, these chords AB and CD are equal, so they will be equidistant from the center. It is also a theorem. Now angle OME, 90, because it is a perpendicular, so 90-degree angle it will make here. And angle OLE, this will also be a 90-degree angle. So perpendiculars create a 90-degree angle. So based on the RHS, right angle, hypotenuse and side, based on this theorem, we can say that these two are corresponding congruent triangles. So if these are the congruent triangles, it means EM and EL. This line and this line will also be equal based on the corresponding part of congruent triangle. So this will be equal. So one thing we have proved, this line LE and EF we have proved equal. Now it is given. What is given? It is given AB is equal to CD is given. It means half of A. If we make half of AB, so it will be equal to half of CD. It will also be equal. So or AB in place of AB, we can AL half for this one. For this half of AB, or we can write it also. Half of or AL is equal to MD, we can write here also. Okay. So this we can write here. So half is equal to half. Now AL plus LE because these lines are equal. So if equals are added to any equal thing, these are equal, AL and MD are equal. So if we will add equals to equal, means from to AL, if we will add equal LE, and in this line also if we MD, if we will add equal EM. So these will also be equal. If equals are added to equals, so they will also be equal. It is also a theorem. So base postulates are there. So in that it is there. So A and E, and here these two lines together we can write AE, and these two lines we can write it as a DE. So AE is equal to D, AE is equal to DE. We can prove it. Now the other part, so one part of the chord we have proved is equal. Now only thing, this part we have to prove EB. Okay, one part we have proved. Now I will run, and the other part also I will prove. Now rest part of the question. Here you see AB and CD are equal. It is given to you. Okay, and you have already proved AE is equal to ED. AE is equal to AD. We have just proved. So if from this line you remove AE, what will remain? EB will remain. So EB will remain. And from this line, if you remove this one, ED. So from the CD full line, you reduce this one, ED. What will remain? EC will remain. It means EB will be equal to EC. Because our one postulate or something is there, if equals are subtracted from equals, it will be also equal. So based on that, this will be equal. Okay, now this question number 2 is over. Now question number 3 onward, we will cover in our next video. Thanks for watching our video. If you like our video, please share with your friends also, so that they can also get benefit of this. Okay, thank you.